All right, so this is the key to worksheet 11.3 part 2. And on this worksheet, in part 2, you're looking at permutations. And remember in part 1, we were looking at combinations. And so when you're looking at combinations, whenever you're having these application problems, you got to ask yourself, does the order matter, or does the order in which things occur does not matter? So if the order does not matter, then it's a combination problem. And there's the formula. If the order does matter, if the order does matter, then it becomes a permutation problem. So the order does matter, it becomes a permutation problem. And so the formula for permutation, so if you want to determine the permutation of n items chosen or at a time, then that's going to be n factorial divided by n minus r factorial. Okay? So notice that the difference between that one and the combination one is the extra r factorial that's in the denominator. So that's the difference. All right. So remember, order matters when you do this. So in number 1, you're going to do 1A and B just like you did 1A and C here. So you got to show that work. Okay. So over here, so remember, n is 7 here, and then r is 2. So according to our formula, this is going to be 7 factorial divided by 7 minus 2 factorial. Okay? And so that becomes 7 factorial divided by, and 7 minus 2 is 5 factorial. All right? And now what I'm going to do is, don't go and say 7 all the way down to 1 and then 5 all the way down to 1. Because look, think about what you're doing. So you have 7 times 6 times 5 factorial, right? So 5 times 4 times 3 times 2 times 1 is 5 factorial. And the reason I stopped there is because there's a 5 factorial in the denominator, and I can reduce this. So those divide out. And so you're left with 7 times 6, which is 42. Okay? And if you want to check your work with your calculator, that's fine. You want to check your answer rather with your calculator, that's fine. So 7, you're going to go to probability permutation, it's already underlined. And then 2, was it 2? Yep, 2, and you get 42. Okay? All right, the next one, you're going to say 10 factorial, so that's going to equal 10 factorial divided by 10 minus 3 factorial. So that's 10 factorial divided by 7 factorial. And again, don't go all the way down to 1. Think about what you have in the denominator. In the denominator, I have a 7 factorial, and that can reduce with part of what's up here. So you get 10 times 8 times 7 factorial divided by 7 factorial. And so those divide out, and so you get 10 times 8, which is 80. All right, and again, you can check. So you have 10 factorial, 10 permutation of 10 items chosen 3 at a time, and you get, oops, so something went wrong here. So let me make sure, 10, 3, so let's do this again. So 10, 3, right? So 10. Okay, so if you're not careful, what happened? See, what happened here was I said 10 times 8. What I should say 10 times 9, right? So I forgot the 9. So sometimes it's a good idea to check your work with your calculator because sometimes you do things quickly and you forget certain things. But that's a good thing to do, is to check your work. So it's not 80. So you can say 10. So we should get 720, right? So let's do this. 10 times 9 times 8 is 720. Okay? All right, so just be careful. Sometimes when you're not thinking, you're doing stuff, you can miss some things. All right, over here, you can just use your calculator. So you saw how we did it here, the calculator. So just do the same thing here. So you're going to say 12. So this is going to be, let me do this here. All right, so you're going to say 12, probability, permutations, and 7. So that's going to equal, that's a big number. So some of you may say, well, God, is that correct? We'll do it again. I mean, it looks like you have it right. So say 12, permutation, and then 7 equal, yep. All right, so that's it. So 3991680. So that's 3,991,680. So if you were to have these 12 items listed and you were picking 12 at a time, you'd have this many list. If you list them all, you'd have this many of them. Okay, over here, do the same thing. You can just do, you can do it in your calculator as you see it, or you can do each one individually, does not matter. So you can say 12, permutation, chosen 3 at a time. Okay, so that's that. Then you can say 8, probability, permutation, chosen 2 at a time, and that's that. And then you can say these multiply these two numbers, and so that becomes 73,920. All right, or you can just see it how you put in your calculator. So you can say 12 probability, and then 3 times, and then 8 probability 2 equal, and you get the same thing. Okay. All right, so these are the application problems. Remember, you just need the setup, goes here, and then the answer goes here. All right, so you don't have, so use your calculator with those. You don't do it like this, because you can easily mess up, like I forgot about that 9 when I was working it out. Okay, so in how many different ways can 7 floats line up for the homecoming parade? So the order matters. You're lining up floats. So if you think about your own experience, the lineup with one, let's say, carnival is different from the lineup of a second one, right? Okay, so the order does matter. So order matters here. Order matters. All right, so the lineup matters. So you're going to say permutation of 7. You have 7 floats, right? And you want to line up 7 floats, correct? That's what that says. You have 7 floats and you want to line up 7 floats. So using your calculator, so 7, permutation 7 floats, chosen 7 at a time, you're lining up, and you would have 5,040. Okay, if order did not matter, let's see what you would get. You get 7 combination, right? That would be a combination if order did not matter, 7, and you would just get 1. Okay, because that kind of makes sense, because you have 7 floats, you're lining up 7 floats. If order didn't matter, that would just be 1 lineup. Okay. Number 4. So in how many ways can 4 of 7 different kinds of bushes be planted along a walkway? All right, so you're planting bushes along a walkway, and the order does matter. So one way looks different than another way, right? So you're going to say permutation of 7, taken 4 at a time. So you're going to say 7, permutation 4 equal 840. So there can be 840. If you listed those ways, there would be 840 of those. Number 5. A club with 10 members is to choose 3 officers, president, vice president, secretary. If each office is to be held by one person and no person can hold more than one office, in how many ways can these offices be filled? Okay, so all right, so you have so the order does matter. So the president, you're choosing the president first, let's say vice president, and then secretary. So the order does matter. So it'll be permutation. You have 10 people, and you're choosing 3 of those. All right. So the order in which you do this does matter. All right. And so you get 10 permutation 3 equal 720. Okay. And then number 6, for a segment of radio show, a disc jockey can play 8 songs. If there are 14 songs to choose from, in how many ways can the segment be arranged? So you're looking at segments. So the order, the 8 songs, you're choosing 8 songs. So 8 songs in order, and let's say you have the same songs in a different order, those are different segments. So the order matters. So that's going to be permutation of 14 songs, and you're choosing 8. And so that's going to be 14 permutation 8 equal that many. All right, so 121,080,960. Okay? All right, so that was the key to worksheet 11.3, part 2. So that's the one dealing with permutations. So remember, the order matters when you're dealing with permutations.